Hello everyone, this is Samuel from Learn Programming Africa, and we are going through today's lesson. Before that, I have promised to prepare a tutorial, but I couldn't have time to do that as I am working on a website for Learn Programming Africa. So I have decided to do the tutorials or the short tutorials before. For example, I'm going to go through what we are going to do today first in as an example based. Then we are going to work on the assignments. That is what I decided, so sorry for the false promises before, and I am going to go through the things now and stay with me. Before that, please subscribe to this channel so that I can I will be motivated enough to do this the entire session. So please be in there, and we are going to do projects, portfolios. For example, I have a portfolio of my own. If actually I'm not going to show you today, I have hosted it on somewhere, so as there is an image on that, and I don't want to show my image still, so I'm not going to show you. I'm going to edit it and show you next time. So let's wait for that. For now, let's start from more pointers and arrays. So I'm going to show you one example of each. For example, we are going to see what double pointers are and what 2D arrays are. So I have prepared two examples here, and the examples are taken from the resources given by the example are given on the resources given by ALX. So I'm going to start just now. So as you can see, there are this is an example. There is a heavy rain outside. If you can hear that, so in advance, but I couldn't do anything about it. So let's get started. All right. The first example we are looking into is going to be a double pointer, which is a pointer to a pointer, and how it is going to be initialized and assigned. So as you can see, this is the first line is going to give us a normal integer assignment or integer instantiation. So this is int number equals to 1, 2, 3. Then the next one is going to give us a pointer, which is just a declaration of a variable. We are declaring a pointer first, so let me do this. Okay, the second one is a double pointer. As you can see, is declared as before it should have a 2 asterisk. So this is a pointer. PR2 is a double pointer. So assigning the address of the variable num to a pointer PR2. This is as a pointer. It is going to hold a variable's address rather than a value. So this is pointing to this number, and the double pointer is going to point to this pointer. So as you can see, a double pointer is pointing to the address of another pointer. So this means you can actually add another int, for example 1, 2, 3, triple, or another pointer. so that you can address another double pointer equals to a pointer to an address to a pointer of which and double pointer. You can do this as well, but for now we are looking at a double pointer. So let's go through this. So if we print a number, if we want to print a number using the number, it is going to be printed like this. If we wanted to print a number by using a pointer, the first pointer or the first order pointer, we just dereference it, dereference the pointer. If we want to print the number using a pointer or a double pointer, we just need to use the dereferencing sign twice, which is this is going to dereference the pointer value or the value that is contained in the pointer. The second pointer or dereferencing asterisk is going to dereference the value of that number. So we are going to look at each by using the printed value. So let's do this. Let's save this and build and run this thing. So as you can see, the value is going to be, the value can be accessed using the variable number, the pointer, the single pointer and the double pointer. So how are we going to do that? We use number first, as you can see here, and we dereference the pointer, the single pointer, and it is going to give us that number. We double dereference the double pointer and we got that number, as you can see here. So this is how it is. So we can also print the address. Pointers are meant to capture or hold the address of a variable. So for example, this pointer, as you can see, is holding the address to a number, and this double pointer is holding an address to this pointer. So as you can see, we can access an address as well with the pointer as well as the value. So the address of a number is ampersand or and this sign, and this can give us this address. As you can see, for example, here address of number is, this is an address sign or an address referencing sign, so it is going to give us this one. An address of a number using a pointer is going to give us this one as well. As it is holding that address already, we don't need to dereference it. The value on this can be dereferenced from the double pointer, so that this is a value of this can be dereferenced by a double pointer. So this address is the address to a pointer is held on the double pointer, but the value of it can be dereferenced, as we know. For example, if we have x equals to 2 and y equals to this one, ampersand x, the address of x is on y, and if we dereference y, it is going to give us 2. That is how we learned about pointers. So here is also what is happening. So for example, address of x is on y, so let's make another z equals to address of y. So this is going to be double pointer, this is going to be single pointer. So if we want an address of x, we can access it using x. This can give us the address of x, and the address of x is on y, so we can call y and get the address. As you can see, we can call a y and get the address as y is equals to address of x, and we can dereference z to get an address of x which is on y. So we are dereferencing z, which is holding an address of y. So dereferencing means go to y and give me the value. The value of y is address of x, so it is going to give me this one. So this is what happened here. So address of number can be accessed from the first order number using the address num, and by a pointer, since a pointer is a pointer value is the address of the number, it can be given to us. The double pointer can also be through the double pointer you can access as well an address of the value. As you can see here, the double pointer is going to be dereferenced to get the value which is on the pointer. So the pointer is going to give us what we need. So that's it. The second one is we can get the value of a pointer using this one and dereference it to get the same value. So these both are the same as this one. So the value of a pointer is an address of a value, so that is why we can do that. An address of a pointer can be accessed from the address of a pointer, and as well as a double pointer which is pointing to this one. So the value of double pointer can be given to us as this one. So a value of a pointer or a value of the pointer, a value of a double pointer can also be gotten by this one, since a value of a double pointer is an address of a pointer, and a value of a pointer is an address for a value or a primitive integer. So this is how you can do you can deal with pointers or double pointer. So you can these are used in real life situations. For example, if you want to keep an address to different values, you can use pointer always. So in real life, let's check what applications use pointers, what real life application of pointers. I think they are used in operating systems and other things. So let's see. Pointers are widely used in OS operating system context, passing large data structure around without copying them again and again. For example, you can use a pointer. For example, an array can be passed by using if an array of a million element, you want to pass an array of a million element to another network context, you can just give it an address to that location, so that you can retrieve that using anything you want. Indirect accessing and hardware register mapping. This is a hardware or a low-level language which is you can do that in Arduinos or other programming language which are low-level. Callback function using function pointer. We are going to look into this in the future. Pointers are used in writing generic function that works on all data types. For example, you can add anything you want to a pointer. So that is the real life applications. For example, let's see, to return multiple values, dynamic memory allocations, and others. Let's see the image part. In tree or in here, you can as you can see, this train is really long, as you can see. So if you want to pass an array that contains this kind of long values to other things, you can use pointers, so that you just use 8 bytes of data to transfer. So that is the real life application of pointer. Let's come back to 2D array. Two-dimensional arrays are a matrix. Matrix are an important element in artificial intelligence and other parts. So you can learn about them by on different platforms. AIs and machine learnings are now popular topics, so you can do that. But the main part we are using matrices are in mathematical equations and artificial intelligence or robotics things. So that is where we use these parts. Let me close this one. Yes, save it. So in C we can use 2D array. This is a 2D array declaration. This means the display or disp variable has 2 rows and 3 columns. So you can do this. For example, let me run this code and see what it is going to do. It is going to ask me for to enter an elements, for example 2 rows and 3 columns. So I'm going to run this. Here I have to remove this one, so let me remove this and okay, let me close .c, yes, and come here and run and build. So this is running this one again. So I'm going to close project and I'm going to run this. As you can see, it is going to ask me to enter a value multiple times. So it is in for loop. So I'm going to enter value for display 00, which is ij is 00 first. So I'm going to add, for example, 2. Then enter a value for display 01. This is for 0 row, column 2. I'm going to add 5. Enter a value for display this. I'm going to add 8. Enter. Then a value for display 1, row 1, column 0. So I'm going to add 11. I'm going to add 3. I'm going to add 7. So this is going to be accepted. If I enter, it is going to go down. So let's see what is going on here. So on this loop, it is going to go through the first element, the first 2 rows, and on the second one it is going through the 3 columns we have. So it is going to ask me to enter a value, and I am entering, and if I hit enter, it is going to retrieve through this one. And if I enter the last digit, it is going to print the value that was stored on this one. It is storing a value on this one. So as you can see, it is accessing the address of the first element, the second element, and storing a value on it. So it is going to dereference it here. As you can see, for example, it is going to display ing, then it is going to print the entire things as follows. So let's see, let's come here and enter here, quit. So as you can see, two-dimensional array elements are the first three element 2, 5, 8. The second three element are 11, 3, and 7. So these are how it is going to print it. So two-dimensional arrays are really important in artificial intelligence and those things. So that is what the lesson of today. So we are going to dive into the projects and quizzes and now. So let's go and work on them. Here, as you can see, what is the size of P in this code? So as it is a pointer, so it is going to be always be 8 bytes, since an address to an address value is going to be 8 bytes long. So what is the size of P in this code? It is going to be 8 bytes. Whatever a pointer is, a pointer has 8 bytes of data. So even if it is double, triple, or anything, it is just holding an address to the point it is pointing to. So that is that. In the following code, what is the value of A00, which is, this is saying go to an array A and go to the first element, which is the zeros index element. Then on there you will see another array, then find another zeros element. So this is saying go to here, which is an array, and from here select the zeros index. So this is what it is saying. So this element has 5 rows by 2 columns. So this is 1, 2, 3, 4, 5 rows, and the columns are inside the next array, the inside array, or the interior array. So as you can see, 2. So the first 5 elements are rows, and the interior 2 elements are columns. So this is saying assign this, and this is saying access the zeros element. This is the zeros element, and in there go down to zeros index. So that is what he's saying, and we are saying this, the reason we are saying this. So in the following code, what is the value of A30? So go to the third index, which is the fourth element. So this is 0 index 2, 0, 1, 2, 3. So we are here, and from here, from the third index, go to zeros, return me the zeros index. So this is saying go here and come get 7 from there. So 7 is the answer. So A30 is 7. From here, as you can see, A31 is go to the third element, the third index, 0, 1, 2, 3. So this is where we are going with this, with the first indexing. A3 is this one, and the first element, or the one index from this element, is going to be, this is going to be the zeros index, and this is going to be the 1. So 1 index. So we are returning 8 from here. So the answer should be 8. In the following code, what is the value of A11? So go to the ones element, ones index. So the first index, this is 0 index, this is first index, and from here bring me the first index. So from here this is zeros index, and this is the first index. So we are bringing 4 back. What is the size of this in this code? As always, this is dereferencing the value. So for example, this is double pointer. If we dereference this one, it is going to be a pointer again. So it is going to be a single pointer's value or size. So it is going to be 8 byte. As you can see, what is the size of dereferenced byte in the code. So as you can see, this is single pointer and it is pointing to an integer. So if we are dereferencing this, we are going to get an integer. The size of integer is going to be 4 bytes, so we are good to go. What is stored inside a pointer to a pointer to an int? So this is an address where an address is stored. So this is what the answer is. What is stored inside a pointer to an int? So this is a pointer to a pointer. So a pointer to a pointer is going to save an address. So that is what the answer should be. So that is that for the quiz. Let's continue to the this part, or the project part, where it says this one. So I'm going to go here on desktop, alx-africa and alx-africa low level. So I'm going to come here using this as well, clear cd desktop alx-africa, alx programming, clear ls, and I'm going to add my project here. From here is what I'm going to add. So I'm going to come up, and I have no directory, I have no such directory, so I'm going to make directory 0x07 pointers, arrays and strings. I'm going to cascade this with cd 0x07 pointers, arrays, strings. So underscore it is strings, and I'm going to end touch, actually readme.md end touch what 0 dash mem set.c end touch. Actually I can separate it by space. Touch, another touch for what? For main.h, I think, and underscore put char.c. So these are what I need. So I'm going to ls here. As you can see, I am inside the directory 0x07 dash pointers dash arrays. Even if I forgot to I forgot this, I misspelled something, I am going to fix it in the future, so don't worry about it. We are going back here, and we have here 0x07 pointers, arrays and strings. So I'm going to open these 3 files, or these 4 files, using my text editor, as you can see here. And on readme I'm going to add here a title saying this is even more pointers, arrays and strings section. So I'm going to save it, and I'm going to close it. And for put char, I'm not going to write anything. I'm going back here. I think it is going to be here, and after going back here, I'm going to copy this one from here, copy, and I'm going to paste it here as you can see, put char is also done. And I'm going to come back here and I'm going to say if not defined, the name of my header file main.h or main.h. What I'm going to say is define again the name main.h, and I'm going to say end if clause. So that is what I'm going to do. So I'm going to say void. Let me come back here and open putchar and come back and copy this one and come back and paste it here and conclude it with semicolon, and that is what happens. And I'm going to come back here and close this one, and I'm going to come back down here and I'm going to do this one, character. So I'm going to come back here and I'm going to add it here. So this is a prototype of a function name set. So I'm going to include what main.h, and I'm going to describe my function here. So I'm going to come here and do this, and after doing this I'm going to copy it here and give it space v, and then what is going to happen is this is a memory set function. I'm going to do s, which is string, and I'm going to come here and b is a character, and what is another thing, n is going to be what, a number or an integer, and return what, return a string. So this is what it is, and let me close and open my function here, and let's come here, write a function that fills memory with a constant byte. So the mem set function fills the first n byte of the memory area pointed to by s with a constant byte b, returns a pointer to the memory area s. So what we are going to do is this one. So let's come back here and we are going to do first unsigned int, maybe a, for example. So we are going to retrieve or we are going to pass through or we are going to loop through s to set b into it. So as what we have been passed, or a pointer to s is going to be passed, but there is a value there. So as you can see, if for example s, for example if car s10 equals to some character hello, some string hello world, maybe this can be another thing. So and n equals to some 5, for example, we are going to, and b equals to some kind of x, for example, we are asked to do what, s equals to s should be for this one x 5 times, and we are going to end that thing. So this is what we should do, or what we have been asked to do. So let me go down to line and retrieve through this, or go through, loop through S and set the value to B. So what I'm going to do is for a equals to 0, a less than n, a plus plus, what I'm going to do is s a equals to b, which is a character b. So what I'm saying is, on the zeros index, make for example, if n is 5, on the zeros index make the character b, on the ones index, on the first, on the second, on the third, and so on. So what we should return is going to be return what? S itself. So it is going to give us what we need. So I'm going to save this and come here, Betty main.h, Betty 0 mem set, and there is a trailing on, let's go here, and on number 5 I have a trailing space, on number 17 I have a trailing space and no semicolon. Parentheses are required on return statement, so these are parentheses, but it is not saying parentheses, just it is saying semicolon is missing. So these are the three elements. No description found for S, B, and N. Ready? S, B, and N. So as you can see, these are needed to be like this. These are needed to be column rather than the thing I have done. So I'm going to save this one as well, and Betty on 0 mem set. Okay, Betty 0 where there is nothing. Git add all, git commit message. What is going to be the message? Memory set done. Git push. It is going to push to the production, and what I'm going to do is I'm going to come back here and test my code, and I hope it is going to pass without any error, and it has passed. So let's go down, and by the way, there is a built-in function memset which do exactly the same. So on memset you are going to pass character S, character B, and unsigned int n, so that it is going to give you what you need. So here, if I change this to change here, include string dot h, and come back here and make here memset, I think, copy memset, then here S, B, N, which will give me the same things. Here I'm going to cut here and save here. If I do this, git add all, git commit message, another way of doing it, git push, and if I check again, it should pass without an error. I can't check. Why? Why can't I check again? I wanted to check. Alright, you can check using this one if you like it, but this also do the same as the previous one, this one. So do check using this one. So I'm going to close this one and go down. Mem copy, which is an exact copy of this one, and what we do is going to be like that, but not exactly. So I'm going to come here and on main.chh I'm going to add this one, and let me get back to you. So as you can see, my battery is dying and I have 26% of it and it is just 90%, but let me do this so quick so that if this is going to stop, I'm now going to able to do it. So I'm going to come here and do this thing, and I'm going to touch this file first, touch one, then what, touch one, mem cpy.c. So I'm going to come back here and open this one, and I'm going to include what, main.h, and I'm going to make this v, then this one is going to be I'm going to do the same. It is saying, it is going to say what, I'm going to do the same thing but copying. We have done this for a string, so write a function that copies memory area. So mem copy function copies n bytes from memory area source to memory area dist, so returns a pointer to dist. So this is what we are going to do. Unsigned int a, then here let's get back and come here, and I'm going to loop through dist for a equals to 0, okay, a less than or equals to less than n, a plus plus, and I'm going to just do dist what, dist a equals to srca, source a, which is what's needed, return dist here. So and here as well I need a semicolon. As you know, I'm a Python coder and I'm not doing well here, and I'm going to make here a description here, memory copy at dist is destination memory, and our source is src is source memory, and come here at n is number of byte to be copied, and what should it return is return string or copied from source. So this is how you can do proper description of the function. This is, for example, this can give a developer that can return to this code, use this code pretty well. So as you can see, we have 11 minutes, and I'm going back here, and I'm not going to check it. I'm going to write another function, copy here, and come back here, paste it here, and I'm going to copy this one, come here, touch it here, V, and I'm going to open it, and I'm going to include main.h. I'm going to do this, and this, and come home. No, not here. So I'm going to come back here, or I'm going to close this, and come back here and copy this one, come back here, V it here, and I'm going to do strchr. This is string character, I think, and at here at S is string given, and at C is another character, and return what? A string. So I'm going back here, and let's get back and read the instruction. String character is write a function that locates a character in a string. Prototype returns a pointer to the first occurrence of the character C in the string, S, or null if the character is not found. So first occurrence of the character. So we are going to search for a character inside a string, so we need a couple of loops. So the first one is to find the int a equals to 0 and b comma b, which are a is going to be used in while loop and b is going to be used in for loop. So let's do this. Let's find out the array of, or the length of the string given. So while is a do what? A plus plus. This is going to do it for us, and while inside that array, here I'm going to add a for loop for b equals to 0, b less than a, b plus plus. What I'm going to do is I'm going to check for a character to be equal to some thing. So I'm going to say if C equals to SB, as you can see, if C equals to SB, I'm going to add a bracket here. If C equals to SB, what I'm going to do is I'm going to reference or add something to it. What I'm going to add is I have S, a reference to an address of something, and I'm going to add B on it. When I'm going to do this, I am adding a where we are, as it is going to be this one. So S plus or B, and I'm going to return here S, which is a reference to the first occurrence of that thing, and otherwise I'm going to return a null reference, which is what is asked. A null reference is this one. So I'm going to add a brace to it. Here as well I'm going to add a brace to it. So I'm going to save this one, and as you can see, my my battery is low, so I'm going to finish this video here and share the entire or the other parts by on my repository. So I'm going to share the code. So these are three, but what I'm going to do is I think 6 or 7.